Hey, hi everyone. A very good morning, good afternoon, good evening, wherever in the world you are joining us from. A very warm welcome, and thank you all for taking the time to be here with us today. It's great to have you. So, let me set the scene for what we are actually here to talk about. If you look around right now, AI has kind of quietly gotten into everything. It's not just the chatbot on a website anymore, right? It's the coding assistant that, your engineers use all day. It's the agent answering support tickets, the thing summarizing your documents, routing your requests, and making little decisions. Today, it's sitting in the middle of real workflows that real people depend on. And here's the thing that nobody warns you about. Getting AI to work in a demo and getting it to hold up in production, they are completely two different sports. The demo is the easy 80%. It's the last 20% that, actually is the challenging part. And that's exactly what we are here to talk about. I'm Shrinath Rao. I'll be your host, and I am the lead quality assurance engineer here at OpenObserve. And joining me, I have Kunal and I have Michael. I'll let them introduce themselves. Michael, would you like to take over?
Sure. Thanks, Kunal. I'm Mike Tuszynski. I'm a principal architect at Presidio. I've spent 25 years in engineering and architecture. I've spent some time in platform engineering in ad tech. I was CTO at a streaming company. Spent 6 years at AWS as a solution architect, and now I work with clients on AI and application modernization. It's funny, I kind of got into AI sideways. I was being asked to advise people on agentic systems, and I really didn't want to advise people on something I hadn't run myself. So I built one for my own job, and I've been using it every day ever since. So it started kind of in spring, and I've been a daily practitioner of it. And so there are a lot of interesting things when you finally get these systems into production that I'm excited to talk about.
That's amazing, Michael. Thanks a lot for that introduction. Kunal, would you like to take over?
Sure, sure. Hey guys. Uh, I'm Kunal here. I'm glad to be here on this podcast, on this panel. I'm Kunal Pitale. I'm an engineering lead focused on the platform engineering practice at Atlantic Health. Typically on day-to-day basis, I oversee multiple AI engineering initiatives, everything from AI-driven automation to AI-driven programs to RAG pipelines to SRE and DevOps duties to dev platform tools like GitHub and the many agentic capabilities it presents. I'm responsible to oversee, govern, and facilitate this to my team at Atlantic Health. Coming from a platform engineering side, I've been in various booths, like being on the DevOps side of things, SRE, working on heavily on cloud infrastructure, telemetry, and also now look overseeing cost controlling measures, specifically with the unpredictable nature of AI agents running in production. So I'm looking forward to share what has worked for me, what has not, what's broken, and how me along with my team has rebuilt it along the way. And we're constantly improving daily by learning the many AI challenges that are thrown at us in production day to day.
Yeah, that's lovely. Thanks, Kunal. Thanks for that great introduction. So yeah, like I was saying, here at OpenObserve, what we do also sits between quality and observability, making sure that something works, making sure that something you can see, and something, if it works, why it works, if it doesn't, why it doesn't. Lately, that's pulled me deep into observability and AI systems around that. Um, you know, uh, that's basically the whole topic today. Without wasting any more time, Michael, I want to invite you to share a few war stories that you've had around this. How you've used AI, how you've designed systems which not only leverage AI but also use AI to drive workflows.
Mhm.
I'll hand it back to you, Michael.
Okay. I mean, so it's interesting, and like I said, I kind of approach this, as first, let me figure out a way to make my job as efficient as possible, right? And so what I ended up building was an agentic system for the pre-sales side of consulting. So all of our client research, all of our qualifications, scoping, writing statements of work. Um, you know, part of the reason it's become a production system because it outgrew my own workspace. It started out as a mono repo, and then I built it into a Claude Code a set of marketplace plugins, right? And now other folks within my group rely on that. So we've adopted these tools in order to share best practices and try to build some consistency in the work that we do. And what we found was, the model itself is not the important part. It's the context that you build around it. It's the rules that you build around it. And if and that becomes very portable to different models. And yeah, different models behave a little bit differently. But maintaining that shared context has been a lifesaver in the agentic systems that I've built.
Yeah,
So I'm
yeah.
taking information from our Salesforce. I'm taking it from our Microsoft 365. I'm taking it from from SharePoint. There, I'm taking it from Atlassian. I'm taking it from any place that I can grab an MCP, and I'm building a rich context that not only I can reference, but then also my teammates can reference.
That's kind of where the value really lies, right? Because when we use these Cloud Code sub agents on our own systems, what we end up doing is we keep loading the memory file that we have with all the learnings that we've had. And these learnings are really useful only when we can share it with the entire team. And that's how we can build a knowledge base which actually benefits us. And that's kind of what reinforcement learning is in AI as well. So Michael, I want to ask you. I kind of wanted to know what were the kind of walls you hit basically while doing this, right? You mentioned that there are a lot of rules that you had to keep track of.
Mm-hmm.
So now let's say I'm someone who's working in a team and I'm setting up X number of rules. Someone else might also do the same stuff. There could be clashes, there could be negations. Let's say I say do it this way, the other guy says no, don't do it this way, do it this way. So some can you share some experiences from your side?
So what, again, this was a learning journey for me. But when I set this up, my initial thought process was set up the agentic system, then check it against the rules. But I learned that was backwards, right? Setting up those rules, what as the artifacts are built, ends up becoming a much more powerful thing. We have an internal standards and best practices playbook that's shared throughout the company. If I ingested that and said, "Hey, when I'm building a statement of work, or I'm building an artifact for a team member," if I reference that first and build the document with that in mind, with that in context, rather than build the document and then have an agent go back and then look at the best practices and say, "Oh, that's wrong, that's wrong, that's wrong, that's wrong," right? You find out, and again, and I'm sure you see it also from a QA standpoint. If you build with the best practices up front, you get much better output as you go. So that was one of the very first learnings.
Absolutely, absolutely. So that's what we are also following here, right? So we spend more time planning and setting something up, and less time actually executing it. That's not how I had started earlier. I used to think that because AI is so fast, we can just get things in motion quickly. But the more time we spend planning, creating a proper PRD, creating a proper process document, and the less roadblocks we hit.
Yeah.
I totally agree with that, Michael. Yeah.
Yeah. And the one other and very interesting thing that came out of that was failure doesn't show up as an error, right? Failure shows up as a really well-formed answer. I think we are psychologically trained that if we see a nice, block of text with nice bullets and everything, our brain looks at it and says, "Oh, that must be right." But it really does take, a human to go read it and say, "Wait a minute, it's outputting something that's completely wrong, that's shaped correctly."
Absolutely, absolutely. That's the tricky part. We have to be constantly on the lookout for false positives, silent skips, stuff like that.
Mhm.
As a QA, like you said, I totally resonate with that. So, Michael, I would like to ask you. You said that you have built this repo where you had all the rules set up, all the collaborations done, where one developer or maybe one individual could share it with the other individual. So can you tell me a bit more about what's the kind of this agentic? I would say it's an agentic AI operating system, right?
Mhm.
Can you share a bit more about that?
So yeah, what I ended up doing was as I built rules and I built skills to build out the various artifacts and research pieces that I needed, I first, again, like I said, it was sort of this mono repo of a whole bunch of different things, and then I started to encapsulate them inside of uh, Claude Code plugins, right, which are really just skills, right? So I used Anthropic's mechanism for sharing skills via the plugin marketplace. So you've seen these all over the place when you say, hey, Claude plugin install and then repo name, right? What I did not realize is that you could create private marketplaces to do that. So that's what I did. I have it set up on a local GitLab. I have a CI running again. I have GitLab CI running against those to make sure that everything's being checked and that I don't regress as I go through. And that's how I'm sharing. And that's the method by which I'm sharing the skills throughout with the rest of my team.
That's awesome. That's awesome. So you have mentioned that what you did, right? The technology was like the least interesting part of what happened, and that's something that usually architects don't admit. But I found it very interesting that you mentioned it. So can you tell me a bit more about that? The surprise element.
Yeah, I mean, what I think was surprising and what became very useful was it wasn't as much we could use any harness. We could use I preferred Claude Code, but some folks were using I think some folks were using Hermes agents, some folks were using Claude Desktop. It didn't really matter. What I really found was that shared context was so illuminating because we'd have a living record of a pursuit, right? So when we were in our internal meetings and we were talking about what was going on, I had a full running record of what was happening for any given pursuit, and it started to act as my second brain, right? I'm sure all of us have had times in any of our work, whether it's pre-sales consulting or engineering development, which I've also been on, when you're like, okay, what was that thing that I was trying to do? What was that? Oh, we had that meeting last week. What was that about? And now I have a very easy natural language way to go back into that and say, oh, right, that was, oh, we had that conversation and so said this. Oh, okay, great. So, I'm able to help bring the team and get everybody onto the same page. And as we migrated more folks into the platform, we started to not to have these meetings where we're just constantly realigning and realigning. It's just, oh, look, there's the context, check it. Okay, we know what the next steps are because the next steps are all very well organized and put together.
That's absolutely bang on. Actually, we also, I mean, I personally experienced this myself, where it's right at the tip of my mind. I want to know what it is, but then it's no longer that. The cognitive learning has become so easy today.
Hmm.
So instead of focusing on the how to do part, the what to do part has now taken over. That's where we
Hmm.
can do more ideations. We can fail faster. I totally agree with you.
Yep.
Um, yeah. So, Michael, I mean, I have another question for you. So, you frame, like you mentioned that context is the product and not the model.
Hmm.
So, if context is the product, then the thing that you have to operate and trust in production isn't the model; it's the pipeline that is feeding it. So, how
Hmm.
did that shift? What did you actually have to keep an eye on a day-to-day basis? Were there some obvious failures that you knew that were coming your way? Were there some issues that were not being resolved at all? Can you tell us a bit about that?
So yeah, when you start to have multiple people update a context, it can get sloppy very quickly. How is it that what I say in a context overrides what you have to say in a context, right? So I set up a system of, I called it hard-won lessons, right? So that what when two people had an point of view on a particular topic, both were captured, and then both were highlighted when something came up. So we never lost context. It wasn't like, oh well, Mike said this, but Jack said this, therefore, and so we're going to overwrite what Mike said with what Jack said, right? In the very beginning, that was happening, right? And I remember sitting there saying, oh, that's going to be a real problem as we go forward, right? Because it's basically whoever updated it last, they get the last word in the context, right? So it was really important to be sure that we had guardrails that protected the context, and that when we came to a real agreement, that the agreement was recorded and the conversation was kept in history for the model to review.
I get it. I get it. That's actually quite insightful. So last one from me for you, Michael, that as these systems, they take more actions on their own, and they're not just answering, but they're also doing right now. If something goes wrong, how does your team actually reconstruct what happened? To what extent are you letting the AI take decisions for you, the model you have built take decisions for you? That actually puts us in kind of a trap, right? How do you solve this?
Yeah, I mean, so part of what I mean that was very much an issue in the early part of it. Is I needed to be sure that my agentic systems were able to undo any job that was done, right? So we can have a chat, and we can have a text record of a chat, but if we're going through and updating records in a CRM, or if we're updating a SharePoint site with information, we have to be able to roll back those things if the agent didn't quite do it right. So if I get a bad answer, now it only takes me 30 seconds to correct, uh, because I've built in good rollback systems into my agentic rules, so that nothing is forever lost.
Got it. Got it. That's perfect, Michael. Thanks for sharing these insightful points with us. I'd like to invite Kunal, and Kunal, if you could just share your war story with us. I'm sure that in your experience, you've also uh, developed AI sub agents. You have developed orchestrators handing over to different agents, and I'm excited to know more about it. Can you please share that with
Yeah, yeah,
us?
sure. So yeah, one of our AI initiatives was to, use build a multi-agent system, and provision that to our internal team out here, where they could, just have a natural language chat with this system to know more information around providers coming from the healthcare space. That's pretty much, the center of our business operations, one of the major ones, and to finding providers based on their specialty, based on their location, availability, based on any rules, whether they take a particular insurance or not. There's a lot of factors, and then there's thousands of providers, and it's not easy on a day-to-day basis to really get the right provider, right, which matches a patient's requirement. And they are very busy, and then their slots get booked like within no time. So we wanted something where we can use an agentic system which kind of carves through all of these specifications and just gets the final answer to any patient, for that matter, and even internal employees. So we built a multi-agent system, where we have a manager or an orchestrator, which kind of interpolates the query of the user, and then respectively calls the specialized agents based on how the query is. Um, it kind of then fetches back the answers from one or more specialized agents and then summarizes that response back to the end user. That's a very simple flow, but there are a lot of calls here. So there's A2A communication between the manager with all the specialized agents. There is inferencing back and forth. There's reasoning, and then there is tool calling for each specialized agents. They make their own specialized tool calls. So you can see, if there is a call being made, the trace from end to end looks pretty long. It takes a good 30 seconds at times. But the end goal is that within that single query, you just serve the answer back to the user, and it would be exactly what you want. And the user at that point probably just does one action instead of filtering a bunch of things. It's overwhelming, but in this, it's a very clean interface, right? To just put in your query and give it 30 seconds, give it 10 seconds, depending on your query, you'll get the answer back. And that's it. Like less than a minute, you find the provider, you find the appointment, and you can further go and book it up. So that was the goal. That is one of our complex systems that we built, and it's doing pretty well. But then it's like any system in production comes with its own challenges. So there's a
Yeah.
lot that challenges, hurdles that we've faced along the way, and yeah, that's been one of my major projects that I'm working on this year.
That's amazing. That's amazing. I resonate with it strongly because the orchestrator approach, right, where one orchestrator works with multiple sub agents and keeps talking to them and they keep reporting to the main orchestrator, and then that's how the whole it's sort of a council of sub agents were sitting on a table and talking with each other, and they're actually building stuff. A couple years ago, this was just a cool thought experiment for me, but now just to see how much it's being used, it's insane, and that's where folks like us, we can talk about it like we're using it in production on a day-to-day basis. Even at OpenObserve, right, we're doing it. So, Michael, I have one follow-up for you. I want to know, I want to move to the costs angle. Michael and Kunal, both of you can get to me. So, when it comes to costs, both of you have developed orchestrators, which talk to different sub-agents. Can you tell me how each of you handled those costs and how much of a problem that was while developing it?
Well, I can start. I mean, being totally honest, when I first got started, I wasn't thinking about cost, right? Like initially, I was like, "Hey, is this something that can get done?" And then I installed some extensions into my harness so I could start looking at what it was costing me and realizing that this was not going to scale properly. Right. So I implemented patterns. I mean, again, I'm primarily dealing in the Anthropic space, but I started making sure that the majority of the agentic work that did not require high level reasoning was going to the appropriate model. So model routing was probably the first biggest cost controller that I implemented. So
That's
Opus
interesting.
Opus for the high reasoning, Sonnet for the middle tier stuff. And then using Haiku when I just needed to read files in and pull things into context.
That's interesting, Michael. What about you, Kunal? Can you shed some light on this?
Yeah. I mean, in the particular context of the project where we have an orchestrator, right? It's important that when you get a user query, it makes the right calls to the sub agents or the specialized agents, right? That is sort of our routing agent, and if the routing itself is flawed, then the whole processing thereafter, where you have another layer of input output tokens getting exchanged, leads to inaccurate information, which is not just about cost, but also frustrating to the end user that now it got an information that you probably never really wanted. So I think one of the areas was model selections, right, as well, where we would kind of make sure that the decision maker or the reasoning, which is performed by the orchestrator, we pick either a Opus or a Sonnet there, let it make a better routing decision, and then also kind of get the information back from the agents and then kind of summarize it really well back to the end user. And if not, make another call, a subsequent call if the answer is not really there and it doesn't match what the user are. And we kind of built this in prompt management of the orchestrator. And we played around with Sonnet and Opus, for example, and then the specializations, which heavily rely on fetching data. They were kind of limited to Sonnet and Haiku, thereby suppressing the cost. There's also one thing where you use smaller model, it's faster, which actually helps in sort of the response time and the user experience.
Yeah, that's great. Yeah, go on, Michael.
Yeah, no, and one other thing that I learned later on after I started doing some more intelligent model routing was caching, right? Doing prompt caching was probably the highest leverage fix that I had, and it's something that you have to design into your prompts. If you put your stable content first and then the volatile content last, you will see a big impact in token usage, because just like any good caching model, store the stuff that's stable and bring it out of cache rather than having to reprocess the entire thing.
Absolutely. That makes total sense, Michael. So I understand that from both of your answers, and that Anthropic has been the go-to model for development. So I want to just ask your opinions about what about using some other models, maybe let's say DeepSeek, maybe Kimi. There are a lot in the market today. Did you ever try maybe like if you ever tried a POC using DeepSeek, and did you ever make a apple to apple comparison, uh, and how did that serve you if you did?
I can
Kunal?
answer this. Yeah. So when we started this project, right? This was we didn't really have like Kimi, for example, offered on on AWS. So we didn't have Kimi as one of the models that we could use. The Anthropic ones were available right up there. They were very well integrated with the Bedrock ecosystem. The SDK calls were really available to test it out and to get a POC get going and then build on top of that. So I believe Anthropic's model were always there. And when we started with, they were, and they had the family of models, not just a single model. We could play around with the cost over there as well, try it out. There were Amazon models also that we have tried out along with, and we have not seen any much of difference, I would say. It's really about choosing the model for speed and reasoning and decision making, and that's really where it matters. Of course, if the tokenomics of this or the FinOps part of this starts exploding, then we'll have to look at the token cost and then determine maybe another family of models that can fit in with that. We haven't reached there yet. The project hasn't, we haven't collected enough, monthly data, which is concerning from the usage, where we have to now get going back to, hey, can we now pick another efficient or cost efficient model? But that's solely there is, and yes, there is trust as well. For example, from a governance and compliance standpoint, you do have a US offering of these model for inferencing. And the other models you mentioned, they don't have a US based, they have a global offering. So if we have to kind of consider only US based deployed models, then Anthropic models were always there, both on the global and the US based stage. Hence, that was another reason.
And I haven't really used any of the open weight models in my production work at Presidio, but I have an entire home lab where basically anything goes. So I've been playing around with, I played around with Quinn. I played around with, I just installed Muse Glimmer, the meta model that came out, and started playing with that. I had built an evaluation harness when I was comparing the Anthropic models to the OpenAI models. So I've just been extending that to the open weight models as I go through. I haven't had enough bandwidth to do it. I've run a couple overnight tests and haven't actually looked at the results yet. But I have been trying to create something of a standardized framework for like, okay, is this going to work? I have an entire home lab where I keep various pieces of my own life organized, and so I try to compare the inputs and outputs of you know I tend to use Anthropic, admittedly, as the standard. Like, okay, I see the request, I see the answer, I see how it's getting there, I see the tool calls that are being made, and then I try to do the same thing against the other
Makes
models
sense.
and try to minimize the number of variables that I'm testing. So I do a lot of that in my own time rather than in production.
Yeah. So that brings me to one of that brings me to one of the questions from our viewers. How are you managing tokens? A single API key for the team, or per user, or per org, or something else?
Yeah, it's per user the way we do it, because there are budgets on top of every key, and you don't want to stop one engineer because someone's just going crazy or blowing it up. So yes, we have per user keys for them to play around in the lower or sandbox environments, because there is freedom to create agents and consume the foundation model tokens and all that, but it's also limited. There's a cost associated with per engineer, so the keys are per engineer.
Yep, we do the same at Presidio. We have each individual has a token budget. There are processes to request increases if needed, and we have dashboards that show usage across the team. Um, you know, the what how what model and how quickly some folks are using that. But yeah, the keys are done by user.
Got it. So I have one more question that I want to put forth. Both of your experiences have aligned, and the common factor, one thing that I see is that green dashboards always need not be true. They are always lying to you. So, what does that scorecard actually need to be for AI? Let's say, okay, a human in the loop will always catch it, who's looking at it every time. But the whole point of doing this is that we need to reduce the dependency of a human in the loop, and we get our work hand fed to us at least 80% of the way. It's never going to be totally autonomous. I think as a race, we are not designed to think that way. What do you think? If there was something, then what would it be which will make the AI tell that to you first before a human does? Uh, Maybe Kunal, you can start.
Yeah. So, I mean, the one thing that I've observed with this agentic system is semantic layer, which does not kind of, lie in traditional systems, right? It's always, whether it's one or zero. And as Michael kind of said earlier, that it's about the accuracy. It just tells you things, but whether it is true and how true it is the whole game, right? So, I mean, evals are one of the most important parts of this game. There is even in the loop evals, there is evals with pre-curated data, and then there are live evals, right? What we have seen is kind of live evals have given us some good understanding of the semantic layer that we put in with respect to prompting, with respect to prompt caching, tool calling, and even tokens that get generated, and how do we even control these tokens and ensure that we never, and there are always outliers, but barring those, if we can control these levers in between, from the user's query to the agent's response back, I think that evaluation in real time is something which kind of gets us to that middle semantic layer that is invisible on dashboards per se, because everything's green there, right? So this is one area that I've come across where even when we are building, let's say, a new feature or adding the new function tool calling, we straight up use the evals right in the first environment or sandbox environment. And it kind of, there are built-in evaluators, and we kind of determine for a function X, what are the closest evaluators you have to consider. And that kind of becomes a part of our, a ticket request, or, this is what we're building. these are the evaluators. Let's see what score it gives us. Gives us 80% above, 90% above. Good to ship it up.
Yeah,
Yeah.
go ahead. I'm sorry.
No. I was just saying that really makes sense. I was going to move on to you, Michael, and I was going to ask you the same thing.
Yeah. I mean, I think the biggest thing that I found is, so whenever we develop a skill, I keep a known good set of examples, and I rerun them on every change, right? So what that involves is, okay, so I know I define what good looks like when I'm rolling something out, and I version and I make sure I know what model version I'm using. I version all my prompts so that I know what I changed and what might have regressed if I'm making changes. I also tend to take a look at, not did the response return a 200, right? But did the task actually succeed? Did the thing that the user wanted to get produced, right? And does it hold up when you open it, right? And we try to measure that at the level of task, not at the level of at the API call.
True. You can only outsource your work to your AI, but not your understanding, right?
Correct.
So that totally makes sense.
Yep.
A quick interruption. We have one more question, one last question from one of our viewers. How to maintain the architecture flexible and scalable? How to maintain that it is flexible and scalable enough to be resilient against the unseen eventual AI changes coming. It's a hot question because the speed with which the AI changes come in are real fast. So, one of you would like to take it?
Yeah, I can take that. I mean, I read in I think it was a piece, probably from Anthropic, that which is basically plan on throwing out your framework every 6 months. That as you develop your framework, you learn these best practices, but the actual code and the actual framework that you build is probably going to get tossed and rebuilt every 6 months, and plan for that, right? Because the cost of actually building it now is a lot cheaper, right? It used to be very expensive, but now it's a lot cheaper. So I had a lot of like legacy rules in my framework that I built out in November, December of last year that were no longer needed. So come April or May, I actually just took the whole thing and just did a full refactor, because and it took me an afternoon, uh,
Yep.
mainly to make sure that I'm staying up to date.
Yeah.
Yeah, I think that's very well put. I think a pluggable AI framework is really, versioned and pluggable AI framework with modularity built in, modularity for prompt management, skill-based management, right? Memory management. If you have a framework where you can have all of these independent, pluggable, and also version together, that helps you to keep iterating faster, uh, not for one, but many AI projects, and also keep a track of it, right? And couple that with the best good practices. Uh, you know, we have 80% of code developed here by using Copilot. So development of code space, the 6 months to 1 year, should not really be scared enough to kind of make changes if something didn't really work.
Yep. Perfect.
So, yeah.
Yeah, I get it. I get it. So thanks, by the way, Kunal and Michael, for those um, uh, great answers. So one thing that I've noticed is that an AI application in production is not just a single request that's going to a model. It's a chain, a user input, a retrieved context, a prompt, a model call, a tool, a handoff to another agent, to an output. And when something goes wrong, the question is never, is the model up or not? The question is always what actually happened along the whole path and where exactly did it go sideways, because that's what we want to know. And that visibility, it stops being a nice to have moment. Real people depend on at that moment. So let me do this thing. Let me quickly show you what it looks like when you can actually see it. I'll keep this to about 5 minutes. I'd like to share my screen, and show you what we're doing here at OpenObserve. Uh, yeah, let me know if you're able to see my screen here.
Yep, you can.
Yeah. So yeah, I'd like to quickly walk you through the whole AI observability that we're doing here at OpenObserve. Like we discussed, right? We need to know when something goes wrong, where exactly it has gone wrong. What are the costs that I'm incurring? What are the spans that I'm seeing in a trace? What's the journey that a particular session is having? So if you see this page right here, I'll go to session straight away, and let me just take past 6 hours. Uh, yeah, this is the sessions page we have at in OpenObserve for AI observability. I'll in O2 AI, this is our O2 AI assistant where we can write any prompt that we want. Like hello O2 AI, and it will reply right then and there, and it will do many actions for me. One thing that it does is whenever I am speaking with O2 AI, asking the AI agent to work for me, uh, I am also reporting the traces that come along the way to OpenObserve, and that's the page we are on right now. So I'm just opening one of such sessions that I've had, where you can see on this screen in front of you. This is the conversation that I had. So let's say you have a system running where you have this multi-agent architecture, and you hook it up with OpenObserve's AI observability module, and this is what you can see. I'll just start with the hello to AI, and it'll give me a set of things that I can do. Let's say I ask it to create an alert for me. It will show me what are the tool calls that went through while creating that alert. It will show me if every tool passed or not. It will show me failures if there are any. And if I just click on it, it will show me what exactly failed. It will say some parameter was missing. It then recovered by itself, and then it will show me the greens as well. And this is a conversational view that I can have. Other than that, on this page, as you can see, you can also see tool hotspots, which were the tools that were called the most amount of times and which turns they were used in a conversation. Cost hotspots as well, where we can see which turn costed me how much based on the LLM model that I'm using. And that's kind of what helps me monitor stuff. And if I go back to this page, on the insights page, if you see, we can see trends over time. So if for the same set of streams, if I'm checking, you can see the cost trend, you can see the token trend, you can see the span trend, latency by model. So if I've just kept an unknown model along with DeepSeek right now to compare. And you can see there are different metrics on which we're comparing with this P99, P95, P90. And it tells me exactly how my AI system is performing. If I've designed an AI observability module, it tells me the AI sub agents how they are performing. And the same, if you go to graph view, you can see that I can see this is the O2 AI, which is this agent that we are talking about. And if you just hover over it, you can see the different types of data stores, queues, agents, tools, models that it's calling. And this is a directional graph, so it can show us exactly how many requests are going, what are the errors. And when we click on it, we can see more details as well if there are any in the past 6 hours. And same goes to agent behavior. On the agent behavior page, we'll see what the you know uh, failure taxonomy is. We can see what are the kind of errors. There was an incomplete response, which was one of the errors. There was a tool error, which was the other one. And what are the kind of looping agents that are running. So this gives me sort of a vantage point and a hawkeye view of understanding the sub agents that I'm building. This is essentially observability for AI, because the whole world today is building AI sub agents left and right. And having a control like this, where we can actually see what the costs are, what the tokens are, input, output, and total tokens are, what's the status of it. And actually uh, being able to go to that particular trace and seeing more details is something that gives us great power. As you can see here, this is the agent workflow that was triggered, and there was a chat and an agent stream that was generated. And in these traces, you can also see the costs that are being incurred at a more specific level if you want. So setting it up is also pretty easy if you go to the data sources part, right? In AI integrations, we integrate with almost every popular ID there is, every popular service provider there is in the world today, and it's as simple as just copying the command from the clipboard here and just setting it up on your system. So uh, if you have any questions, please hook us up. Uh, Ask us any questions. We'll be happy to answer that for you. Yeah, that's kind of what I wanted to share. Thanks, Michael. Thanks, Kunal. And the main part here, right? What I want to conclude is that the best practices part. I would like Kunal, you to maybe start giving a final closer from your side.
Yeah, sure. If I have to kind of go back to day one and take a look at this project and everything that we learned, so there's a new one. I would never deploy any agent without an open telemetry instrumentation, right? Knowing that, the number of tool calls, the number of traces, spans that kind of tell you everything more than just numbers or greens or reds and response times, and those metrics are important. But when you get into any agentic setup or architecture, you do want, especially at enterprise level, you have a lot more to kind of visualize. So never deploy without any hotel instrumentations. Enforce steps and observability at token levels because cost is important. You don't want to be burning tokens and not getting the results. So the efficiency optimization should be evals, should be built in right upfront. And run async evaluations on every traces to see if there are silent fallbacks, hallucinations, where, as Michael said, 200 is okay, but the quality degraded.
Absolutely.
Yeah.
Absolutely. That's perfectly right. So Michael, like if you were to, launch the same system that you've built again today, what would be one practice that, you would put in place from day one? Your biggest
Well,
learning?
I think the biggest learning, I probably came to observability and evals later than I should have. Putting those up front, I think makes a lot of difference. Especially, I'll take a step back from the technical and actually speak more to the financial and business stakeholders, right? Because if you're building a new agentic system, if you're proposing agentic system to solve a particular business problem, you need the evidence to go to those business stakeholders to say, here's it's working, and oh, by the way, it's not going to cost more than if we had just assigned 3 people just to do this work, right? So it's not only from a technical am I right, but it's also how I justify the existence of this particular piece of software is especially learning in a large organization like Presidio, making sure that you have that evidence and have that and have that observability and guardrails built in at the beginning. Now, I think whenever you're on a journey, and this journey that we've been on, all of us collectively, from an AI standpoint, I mean, it's been a rocket ship. I've never seen technology, move this fast. I remember being really annoyed when they were releasing React versions every other week, and we were struggling to keep up with like React back in the day, right?
Yeah.
And now it seems like every other day something else is
The
happening.
the iterations have only gotten smaller,
Yeah,
and
yeah. So it makes
that's
observability an even bigger argument, is my point.
absolutely. Thanks. I mean, thanks, Kunal. Thanks, Michael. I mean, that's been our time. We've already overshot by 5 minutes, but thank you so much for staying with us. And huge thanks to both of you. Real stories, real scars, and genuinely useful lessons. And thanks to everyone who joined. The one thing that I'd like to say before concluding is that your AI system will always find a way to confidently lie to you and be wrong. The only question is whether you'll be able to see it when it happens. And observability being set up for AI is 100% solution for it. Thanks, Kunal. Thanks, Michael. Have a great day ahead.
Thank you.
Thanks, Tree. Thanks, Michael.
Take care. Have a good one.
Take care, guys.
Bye.